welcome to True Projects. In this video, we are going to explain about the project, which is efficient and accurate cloud-assisted medical pre-diagnosis with privacy preservation. So before getting into the execution, first let's understand what is the project about. So imagine that you are a patient where you're seeking for a pre-diagnosis for ongoing health issues through a cloud-assisted medical service. So, this service allows healthcare institutions to use extensive medical data to develop and predictive models, which enables you to submit health queries and also receive timely results based on your personal health information, which is PHI. But the rise in medical data breaches, which raises serious concerns about the reliability of these cloud servers. Often they are managed by profit driven companies which are vulnerable to external attacks. So, this highlights the critical need to protect sensitive information, that is, health information, while still providing efficient medical assistance, emphasizing the importance of secure frameworks in cloud computing for healthcare. Let's take the challenges in the cloud assisted medical pre diagnosis. While these technologies simplify health data analysis and provide quick results, privacy and data security are the main concerns. So these are the significant concerns which are nothing but privacy and data security. Traditional similarity metrics such as Euclidean distance and Mahalanobis distance. So these distances, they do not account for relationships within psychological data. They have limitations because they do not account for relationships within psychological data. For instance, height and weight are correlated. And using Euclidean distance, so by using this Euclidean distance, it may overlook these connections, leading to lower classification accuracy. And coming to this Mahalanobis distance, so this distance captures correlations effectively by considering variance and covariance. But its computation involves a covariance matrix, complicating a privacy preserving measures. So therefore, while Mahalanobis distance can enhance diagnostic accuracy, ensuring patient data remains secure poses a significant challenge. So what are we going to do in this project? In this project, we address privacy and security challenges in cloud assisted medical diagnosis. So the project proposes an innovative framework for secure disease diagnosis. It utilizes matrix encryption technique to protect medical records, ensuring patient confidentiality during processing. So in this project, we are using matrix encryption technique to protect the data. So this is the matrix encryption technique. And for accurate pre-diagnosis, the project employs k nearest neighbors. So in this project, we are going to employ the k nearest neighbor and also Mahalanobis distance, which enhances the data analysis. So patients they can securely query the outsourced model on the cloud server, that is Drive HQ. So in this project, we are using Drive HQ Cloud to store all the records, allowing them to receive pre-diagnostic results without exposing their personal health information to any other third party. So this approach combines high diagnostic accuracy with strong data protection measures. Moreover, as the extension to enhance the disease prediction, in this project we are incorporating ensemble machine learning models which are nothing but random forest and XGBoost. So by combining multiple models, these algorithms improve diagnostic accuracy. Ensemble model is nothing but, for example, if you are taking random forest, it will combine multiple algorithms and improves the accuracy. So by combining multiple algorithms, these algorithms they improve diagnostic accuracy and also efficiency even with encrypted data sets. So in this project, when we upload the data set that will be encrypted and on that encrypted data, we will be doing the prediction. So this approach leverages the strength of each model, speeding up the data processing and preventing overfitting, which leads to more reliable predictions in the real world scenarios and while preserving the patient privacy. So this is all about the theoretical concept of the project. So now coming to the requirements, we need backend languages. I mean, we have used Python as a backend language, JavaScript and Solidity. So coming to the requirements, to implement this project, we need some requirements. And backend languages which are used are Python, JavaScript, framework used is Django, front-end languages are HTML, CSS, JavaScript, and Bootstrap 4. And hardware requirements are processor of i5 and above, RAM of 8 GB and above, ROM of 20 GB and above, and operating system of Windows. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So these are the source code files which are important for the project's execution. So coming to this cloud assisted folder, inside this folder there are Python code files that are intended to be dynamically loaded into the project code during runtime. And this is cloud assisted app folder. This folder comprises of two subfolders and some Python code files. And two subfolders are, one is static and the other one is templates. So coming to static, it contains CSS, JavaScript and Bootstrap files. These files, they contribute to the visual and interactive aspects of the application. And coming to the templates folder, in that folder we have HTML templates, I mean HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. And coming to the Python code files that will be executed during the runtime of the application supporting the project's functionality. And this is the dataset folder in which we have the dataset. So this is the heart disease dataset used in this project to train the models to predict the heart disease. So this is the dataset used in this project. And these are the important attributes which are important for predicting the heart disease. So these are the independent attributes which impact the dependent attribute, which is target variable, in which we have the heart disease predictions. So 0 represents no heart disease and 1 represents the heart disease. Now close this. Here in the test data folder, I mean test data file, we have test cases. So these are the test cases we'll be using in the front end to predict the heart disease. Close this, get back. This is the model folder. In this folder, we have NumPy files which contain the algorithm information. This file will be loaded into the project code during runtime. And this is the manage.py file. It is a command line utility that comes with the Django. It provides various commands for managing Django projects, including tasks like running the development server, creating the database tables, applying migrations, and more. And this is the run.bat file. Instead of executing this project through command line interface, we have created Windows bat file to execute the project. Now we have to double click on it to execute the project. So double click on that. Here, if you observe manage.py file is compiled, it takes time to host the application. So Django framework will host the application at the local address, which is the local host and the port. Now copy this local link provided by the Django framework. You can paste it in any web browser. So I prefer Google Chrome. I will paste it in that. Paste the link here at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Django framework. So here in the home page, we can see different links. One is admin login, patients login, and new patient sign up here link. So first admin will be logging in and then he will be uploading the dataset. He will train the machine learning models to predict the disease. After admin trains the dataset, then only patients will be able to log in and predict the disease according to their health condition. So click on admin login to train the dataset. So give the username and the password. Now click on log. Admin has logged in successfully. So this is the admin dashboard where he can upload the data set. He will be encrypting the data and outsource that encrypted data through Trapdoor to cloud, and he will be training the models. So let's upload the data set. Click on upload data set. Click on choose file. Let's upload the heart disease data set. Click on open and now click on submit. So data set is uploaded successfully. Now let's encrypt it using matrix encryption technique and trapdoor it to the cloud. So click on matrix encryption. Here dataset is encrypted and this encrypted data will be stored in the trapdoor and that will be outsourced to cloud. So open Drive HQ for seeing the trapdoor encrypted data. So this is the trapdoor encrypted data. So in this file, all the encrypted data is stored and this trapdoor file is stored in the Drive HQ cloud. Get back to the application. Now let's train the model. So click on Run KNN and SVM. So here if you see, we can observe that the heart disease dataset is trained on all the models, that is with the proposed KNN, SVM, random forest, and XGBoost. Among all the models built, we can observe that XGBoost model, which is the extension, got the highest accuracy. So it got the 98% accuracy. Now let's click on computation graph. So this is the trapdoor computation cost chart where on x-axis we have number of generations and on y-axis we have the computation cost. Now let's log out. Now let's sign up as a new patient. So for that, click on new patient sign up here link. Let's enter all the details of the patient so that he will be able to sign up. So username is Kumar, give his password, give his contact number, give his mail ID, give his address, and now click on register. So user Kumar has signed up successfully and he can log in to diseases diagnosis. So click on patient's login link. Here give his username and the password. Click on login. So user Kumar has logged in successfully. Now let's diagnose his disease. So click on diagnose your disease link. And here we need to give the test data. So that test data, for that test data, we have some test cases I have mentioned you already. So let's open that. In this folder, we have the test cases. So first we have to give the age. So let's try first using the first record. So the age is 54. Here we have to give 54 is his age. His male, which means 1. CP we have to give it as 0. Test BPS is 122. Cholesterol is 286. FBS is 0. Rest ECG is 0. Talach value is 116. Exang value is 1. And old peak is 32. Slope is 1. CA is 2 and thal is also 2. So these details, they will be encrypted and then they will be stored in the cloud. So click on submit. So this is the data that we have given, which is encrypted. So this is the encrypted form of it. So this is the encrypted form of it. Based on the given details, here we got the prediction as no heart disease detected, which means the patient has no heart disease. Let's enter some more test cases. So now let's enter the second record where the age is 71. She is female. CP is 0. Next, test PPS is 112. Cholesterol. FBS. Resting ECG is 1. And Talach value is 125. Exang is 0. Old peak is 1.6. And the slope would be 1. CA and TAL are 0, 2. Now click on submit. So here we have uploaded the details. We have given these details. So this is the encrypted form of that data. And here it has detected as heart disease detected. So in this way, patients, they can give their records. They can give their all the health records. Then after giving the health records, system will be encrypting those records and send it to the cloud. And then it will predict the disease as whether the person has their heart disease or not. Now click on log out. In this way, patients, they can log in and they can detect their disease. Through cloud, all the data of the patients, it will be securely stored. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.